So let's talk about solving equations a little bit and talk about graphing. Now I've been having you do graphing on ALEKS, just graphing points and identifying quadrants and things like that, right? Okay. But we want to actually start talking about graphing things. And so we talked yesterday about looking at an equation and knowing how many solutions there are. Remember? When you look at this equation right here, let's see, let me make it simple. 2x plus 7 equals 11. How many solutions do you think there are to this equation? One. The x right here is to the first power, and that gives us an idea. There's probably one. Could there be infinitely many or none? That's a possibility, but probably one, right? Hey, look up here. Don't be working on set 31 right now. We're doing something else. So I'm going to solve this equation, but I'm going to do it a little bit differently than you've seen before. And then I'm going to show you something that's kind of cool. So first of all, let's just solve it the normal way. Subtract 7 from both sides. 2x equals 4. Divide both sides by 2. And there's our one solution. Okay? But I'm going to do something a little different that you probably haven't seen much of before. I'm going to solve this equation for 0. And what that means is I'm going to get 0 on one side of the equal sign and everything else on the other side. Okay? And it's really easy. If I want a 0 right here, could I get a 0 right here?
Subtract.
Say it. Subtract 11. Yeah, subtract 11. I can subtract 11 from both sides of the equation, and this gives me 2x subtract 4 equals what? It equals 0. Okay?
Teachers, all the seniors should be back in class by now.
Hopefully not in our class, right? Okay. Now, why would I want to do that? Well, I can do some tricky stuff now. Instead of putting a 0 right there, I can now put a y right there. In fact, I could even switch this around and say y equals 2x subtract 4. Now, does that look familiar to anybody? Who's seen equations like that before? We all have, haven't we? And what did you do with equations like that? You talked about the slope, and you talked about the y-intercept, and you graphed them, and all that kind of stuff, didn't you? So we're going to start graphing a little bit, and on ALEKS, I've given you the little thing where it gives you a table, doesn't it? And you have to just fill in. It says, put this number in for x, put this number in for x. And you put numbers in for x, you get numbers out for y, and you kind of see what happens. And so we're going to graph back the old way. I don't know if you remember doing this before, but I'm just going to find some points, some ordered pairs that make this equation true.
They are ready for the swim team now in the little theater. Swim team, go to the little theater.
So I don't know about you guys, but I am extremely lazy. And I like things to be as easy as possible. Do you? Okay. So I don't just put any numbers in for x, okay? I pick my numbers very carefully, okay, in my laziness. So can you think of a number that might be really easy to, yes, Thomas?
0.
Oh, yeah. That's the one, right? We put 0 in for x. 2 times 0 subtract 4. What do we get? We get negative 4. In fact, could we kind of just tell? Yeah. Let's put another number in for x. 1. What else can we put in? Negative 1. 5.
Oh, negative 2.
Can we put in anything we like? Now, we kind of want it to fit on our graph here. We don't probably want to put in too big of numbers or too small of numbers. And you know what? I'm not going to put in 1 and negative 1 because sometimes when we put in numbers that are too close together, it actually makes it a little bit hard to be accurate with our graph. We want numbers that are a little bit far apart. So So I would say let's at least put in a 2. Can we at least put in a 2? And that gives us 4 subtract 4, which is 0. And then if I put in a negative 2, I always put in, or a 2, I always put that in a negative 2. So I usually put in 0, a small positive, a small negative, and that gives me enough to go on, okay? So if I put a negative 2 right here, what does this become? Negative 4. Subtract 4 is? Okay. Now we start looking at these points on our graph. 0, negative 4. 0, negative 4. 2, 0. 2, 0. Negative 2, negative 8. Negative 2, negative 8. And what do you guys start to notice about those points? Oh, that's the word. They're linear. It's a linear equation. All of the ordered pairs that make it true will fall along this line, right? Okay. Now, what would happen if someone else, like Jem's like, you guys are stupid, I'm putting a 5 in. Yeah. So she's like, okay, y equals 2 times 5 subtract 4, which is 10 subtract 4, or? Okay. And Jem graphs the point 5, 6. 5, 6. Does it still line up? Yeah, it's still on the same line, isn't it? Could I put 100 in? It would be kind of hard to graph on our graph, wouldn't it? But it would work. We can put in, heck, can we put in a half? Will that work?
Yeah, but it's
2 times, oh, I don't think it's that hard. A half, subtract 4. Isn't that just, yeah. It's just 1 subtract 4, which is negative 3. So we can go over a half and then down 3. It's fine. Okay, we can put in any points we like. Now, how many points do we really need in order to graph the line?
3.
Now, we always do 3, but how many do we really need? 2. There's a guy named Euclid who lived 2,500 years ago, and he said through any 2 points, there's exactly 1 line. Through any 2 points. So if I draw 2 points on my paper, how many lines can go through both of them?
1.
Yeah, there's just 1 line. That's it. There cannot be more than 1 line that can pass through those 2 points, can there? Now, if that's the case, why do we always do 3? Why do we always do, you make these tables, you always do 3 points, you graph the 3 points, why do you always do 3? Yeah, maybe that would help us find the y, but even if we don't do the y-intercept, do we usually do 3 points. We have you guys do 3 points. Do you think I do 3 points when I graph a line? No, I don't. I do 2. Why do we always ask you guys to do 3? What's that? Yeah. So if you do 3 points, guys, and you get 1 point here, and 1 point here, and 1 point here, which line are you looking at? Is there 1 line that passes through all 3 of those? No. Something's wrong, right? But if you get 3 of them that line up nice and neat, what do you know? Did you do it right for sure? Yeah. So the reason you guys do 3 is because you're not that good at it yet. It's just to make sure. If you do 3 points and all 3 of them are linear, they all line up, then you know for sure, okay, I've done that right. But if you get 3 points that don't line up, then you need to go back to the drawing board a little bit. And until you get a little better at it, that's why we ask you to do the 3 points. But it really only takes 2 to graph a line. Oh, what else did I want to show you? Remember back when we solved this thing? Remember that? And then we graphed the points. Think about this again. What does x equal? Look at our equation, look at our line. Where does it hit the x-axis? At 2. Is that a coincidence? I think not. It's not a coincidence. Now you guys, last year it was all about the y-intercept, wasn't it? Which is great when you're graphing the line, but really the x-intercept. Do you think the x-intercept might be important too? Yeah, it's way important, and we're gonna talk a lot more about that this year as well. So, graphing a line. If I give you an equation, ready? Here's an equation. Y equals, should I make it a little hard? 1/2 x subtract 6, okay? I want you guys to do some points. I want you to put some numbers in for x and get some numbers out for y, and then I'm just going to call on you, and we'll see what we come up with. Do 3, and do different ones, you know. Write the equation, replace x with a parenthesis, put the number inside. Sound familiar? Yeah, we didn't learn that for nothing.
What is 1/2 times 1/2?
It's 1/4. But you know, remember how I told you I was lazy? I'm going to put numbers in that are easy to work out. So I'm not going to put a 7 in because half of 7 is kind of a pain. But I might put an 8 in, because what's half of 8? Yeah, you guys can do half of 8, can't you? You can do half of 10. You can do half of -2. You can do half of 0. Yeah. What's that?
You're dividing because I put a 2 in and then it turned into 1/2.
Well, if you put a 2 in, 1/2 of 2, that's 2 over 1, isn't it? See, 1/2 of 2 is 2 over 2, which is 1 subtract 6. So if we put a 2 in, I think we get 1 subtract 6, which is -5. So 2 -5, there's a point.
Wait, can you go back to the equation?
Oh, didn't you write down the equation?
I'll write it down. I'll just look it up. I will know.
Okay. Easton, give me a point.
0.
0 what?
0.
Well, no, you got to put a 0. What comes out when you put the 0 in?
Oh, -6.
Okay, 0, -6. Right? Give me a point.
4,
4,
4.
4. 4, 4. Now we have 3 points here. Where's our line? Sometimes when you do this, you graph your 3 points, and one of them's wrong. But it's really hard to figure out which one is wrong. And so what I found was, rather than going back and trying to figure out which one is wrong, what you do is you do another point. You put a different point in there. Shannon, you got a different point? Didn't you put a number in for x? 2 negative 5? 2, oh, you got the 2 negative 5 when we already did. What do you got, Thomas?
8 negative 2.
8 negative 2. 8 negative 2. Do you see how that kind of gives us a clue which one might be? So I think maybe this one instead of 4, 4, is it possible this one was 4 negative 4? Yeah? So a lot of times when you guys are trying to figure out which one of your 3 points is wrong when you're graphing an equation, you keep doing the same mistake and it's really hard to tell. That's what I do. So I just do a 4th point, and then if I get 3 of them that line up, then I'm like, good to go, right? Anybody have a different point?
10 negative 1.
10 negative 1. Different point? Negative 2 negative 7. Does it matter what number you put in for x? No. You're going to get a combination, you're going to get that ordered pair that's going to be on this line somewhere, isn't it? And once you kind of have a good idea where that line is, there it is.
And that's one would be negative 4, negative 8.
Negative 4, negative 8. Negative 6, negative 9. Negative 8, negative 10. Yeah.
I think it'd be solved that one.
Now you can put numbers in that maybe aren't quite as fun. So we could put in a 7. Half of 7 subtract 6. Can you guys do half of 7? 3.5. 3.5 subtract 6. That's a little iffy. Positive or negative? Negative. Negative 2.5. See, because your half would get you up to 4, and then 2 more would get you to 6, wouldn't it? That's the difference. So negative 2.5. So 7 negative 2.5. 7 negative 2.5. Work? Sure. You can put a 3rd in, you can put a 4th in. Now, my laziness takes over though. I gotta say. If I had an equation like this, y equals, well, 1/2, I put in like 0, 2, and negative 2. Or 4 and negative 4. I put in numbers that I can take a half of. If the equation says a 1/3 x plus 10, what do you think I'm going to put in? Well, 0, obviously, right? What else? 3. What's a 1/3 of 3? 1. And then I'm going to put in
Negative 3.
negative 3. See, because it's super easy. I can write on my paper, I'm going to put a 3 in. And that just gives me 1 plus 10, which is 11. And then I can put a negative 3 in, which is negative 1 plus 10, which is 9. I've already got the 3 there. I just changed it to a negative. Okay? If it said 1/4, what would I put in?
4,
4 and
0,
0 and negative 4. Or maybe an 8. Or a 12. Something I could take a 4th of, right? If it said 5th,
10,
5,
yeah.
0.
Yeah, there you go.
25.
Okay. And even if it says y equals 2/5, I'm going to put probably a 5 in, because at least the 5s would cancel and make my life better, right? If you think ahead a little bit, you got it. All right, so who's done this before? All right. Did you learn a little something today? At least how to be lazier, I guess, huh? Did I teach you that? I hope. Okay. So we're doing set 31 today, and then we'll do some graphing tomorrow on Alex.
Okay.